It's so thin.
Oh, righty, okay. Oh, is it on?
Yeah.
Alright, so, remember that if we're asked to solve a quadratic, okay, you've got a couple of methods that we've been looking at. We can either factorize them or we can use that quadratic formula. But it doesn't matter which method we choose, remember they always have to equal 0 before you can start solving. Okay, so rearrange them if they don't equal 0 first. Now, how many solutions do we get when we solve a quadratic? Two. I don't know if you've noticed, but often when we're solving quadratics, one of them has been a negative value and one of them has been a positive. Not always, but that's often been the case. Now, when it comes to application of solving quadratics, what happens is that sometimes we need to look at the solutions that we get and say, well, hang on, that one doesn't make sense, okay? Now, the process of solving quadratic for an application problem is exactly the same as anything else. They will give you a situation, okay? So in this case, they've been talking about a right angle triangle. They will give you algebra rather than give you all numbers. You have to set up an equation and then solve it. Try really hard to stop the TikTok.
Okay.
Okay. Now, here's the thing that confused some people, and really it shouldn't, in that sometimes the questions will say, show that, and they'll give you an equation. Okay? For some reason, people get freaked out by that. I think they're the best ones because you know what answer you should end up with. Okay? You know the equation that you're supposed to have in order to then carry on and solve it. If they don't say show that, then you've got nothing to gauge it. Show that questions or no show that questions, the situation is the same. So here, they've told us that the hypotenuse of a right angled triangle is 2p centimeters. Okay, so it's represented by 2p. The lengths of the other two sides are p plus 1 and p plus 3. Calculate the value of p. Now, I've said here, sometimes a sketch height. They talk about a right angle triangle, so probably I would suggest draw a sketch. But I'm a sketchy person. I'm not that I'm good at drawing. That sounded really awful as well, didn't it? I'm sketchy. That's fair. I'm the kind of person that needs to have a bit of a visual aid when I'm doing these things. I don't like things too much in my head. My head can't cope with it. So here's my sketch. So we need to start labeling stuff. So my hypotenuse is 2p. Which one's the hypotenuse?
It's diagonal one.
Opposite the right angle, yeah? So that was 2p. The other two sides are p plus 1 and p plus 3.
Doesn't matter.
It really doesn't matter which one's which. I'm going to label this one p plus 1 and
Yes, I
p
do.
plus 3 simply because this is longer than this one, obviously.
Oh,
This is p plus 1 and this is p plus 3.
Wait, so basically it means like 1p and 3p?
No. It means
p plus 3
and
p plus 3.
So p we could work out to be 7. So that would mean this one would be 8
Oh.
and this would be 10.
And that would be 14.
Oh, like
Yeah? Okay, so you've got to remember the difference between something more than or double or treble or times those numbers. Okay?
Okay.
Alright, so now what rule do you think we're going to use to help us? What rule can we use to help us?
squared plus b squared.
I know you did, darling. However, you have been known in the past to also just shout stuff out. To be fair. I know you were very good, and I appreciate that. Julia, try not to call things out. Alright, so Pythagoras' rule would give me what statement? What would I write down?
p plus 1
plus b squared equals p plus 1 squared.
p plus 3 plus p plus 1 squared equals 2p squared. No, yes, 2p squared.
Okay, now, I put put brackets around everything. You were very good at telling me my brackets for this one, not so good for this one. Now the problem if you didn't do this one is that I think a lot of people would have written 2p squared and just left it like that. That would be wrong.
Wrong.
Because the whole side has to be squared,
And the 2.
which means the 2 as well as the p. Yes?
Yeah.
Alright, so now I've got some squaring going on. How am I going to deal with those?
Square root.
Julia?
Well, you're gonna do p plus 3 and p plus 3, and then you're gonna FOIL it.
Nice. So I'm going to actually write my brackets out because I want to make sure that I don't make a mistake and try and do stuff in my head. I can do this expansion though. What's 2p all squared?
4p squared.
Very excitable today, Julia.
Thank
I
you.
love it. So hopefully you'll have as much energy for the rest of the day.
Me too. 4.
Because what is
Oh,
2p?
sorry. I thought you were adding up to p's. Never mind.
Yes.
Okay, so foiling. P squared. Or maybe I should do a different colour.
Wait, Miss
P squared.
What? Never mind.
First.
So, p squared plus 3p plus 3p plus 9
P plus squared.
plus
P squared plus 1p plus
1.
Equals 4 squared p.
Okay.
Oh, whoa.
Oh. So, there my brackets expanded. Lovely jubbly.
Wait,
Bless you.
wait, where did we get the 4 from?
2p all squared. So that means 2p.
Oh, 2 times 2.
multiplied by 2p.
Oh,
Yes,
Sorry.
I did ask that last time, but that's okay. Okay, it's early.
she was crying. It's okay.
Alright, so what should we do now?
Collecting
add
like
up,
terms.
collecting like
Let's
terms.
like terms. Okay, so I've got p squared here. Let's just deal with the left hand side first.
2p squared.
Ooh.
2p squared. They're plussing, so it's 2p. They're plussing.
What the heck? Oh, it's just 2 plus 2.
There's time
No.
thing, Danny.
No, I love all these conversations.
Thank you.
So you've got p squared plus p squared.
So you're plussing.
That's 2p
P
squared.
squared.
So remember your term is your
Right.
p squared. Yes?
Can I do the next one?
What, you can do it right this time?
Yeah.
Oh, Miss Harrison. Oh gosh. Oh, I'm sorry, Ben.
that was good.
Sorry, no, what?
That was
I'm
really good.
like trying to make contacts
I'm
come
sorry.
out.
I'm sorry, sweetheart. Yes.
9, 10, 11, 11p.
8p.
No, look. There's
8p.
Something's wrong with her.
Okay, 3p plus 3p is 6p. Plus p plus p is 8p. Almost, Danny. Danny, how do we feel about the next one? Can we do this one?
Wait, it came out. Oh, 10. Quick maths.
Trick maths.
She got that. Okay, so what did we say? We're trying to solve for p. So what kind of expression is this? We need to look at this and say,
Algebraic.
Equation.
No.
oh, is this the
Solve.
But what kind of expression? What kind of equation?
Quadratic.
Okay, yeah. So that's what we're doing. This is the topic we're
Where's
looking
the
at.
0?
Okay, well, so it's a quadratic equation because it has a p squared and a p in the number, okay? So it has a p squared in it, so it's a quadratic. But what did we say has to happen when we're solving quadratics? It has to
Equal 0.
equal 0. So does this equal 0?
No.
But can we rearrange it so that it does equal 0?
Possibly.
Yes, you can.
Yeah.
Yes, because all we have to do is to get rid of something from one of the sides.
Yes.
Now, I've got 2p squareds here, but I've got 4p squareds here. So actually what I'm going to do is I'm going to subtract each of these terms here on the left, and they can be joined with the one on the right. So I'm actually going to have my 0 on this side, simply because I have more p squareds over here. Otherwise I'll end up with a negative p squared term. You all understand that?
Yes.
Lydia, try hard, darling.
Okay.
So I'm going to take away the 2p squared from both sides. So I have 2p squared. And then obviously I'm going to take away the 8p. So that's minus 8p. And I'm going to take away the 10. So that gives me the minus 10. Okay?
Wait, but would you aren't you minusing the 8 from the 14?
Yeah, sorry, I just wrote it in a line underneath. I should.
Can I write it on the other way around, please?
You can write it wherever you like. Sorry, what? Sorry, what's wrong?
So is the 4p like not there anymore?
No, because we had 4p
It
squared.
subtracts.
Take away 2p
Oh,
squared.
yeah, okay.
That equals me 2. That's what. That's the thing. Alright, so far so good, yes?
Yeah, so far so good.
So, let's just retreat back to what I was saying at the beginning. You may have had a question that said, part A would be, show that 2p squared minus, what was it?
I don't know. It's a number.
8p minus 10 equals 0. Okay? So that could have well been the first question. So if we've been asked to show that, we would do exactly what we need to do by using the information we've been given mathematically, Danny and Haley. So we'd look at the mathematical information we're given, set ourselves up an equation, rearrange it, and hope that we end up with that. And we did. So we followed that show that. Do you understand the concept of the show that question? Yeah? So it's a help to you because you know what you need to end up with. Right, so now we need to carry on and solve it. Now, with factorising, remember that yes, we have we've got a quadratic, so we're going to have 2 brackets here, but always what you should do is look out to see, is there a common factor?
Yes.
Is there something common to all
2.
of those numbers? Yes. I think 2. So we can put the 2 to the front first.
Ah, shoot, I did
And that will
wrong.
give me p squared minus 4p minus 5. Okay? So if possible, always bring a value to the front if you can. Okay? That will mean that your factorising is going to be heaps easier later on. Now the 2 has no effect on anything. It just sits there while we're working. So the 2 sits there, and we've got our 2 brackets. So we're looking for, so obviously it's p at the beginning, because it's just p's. Is that it?
PP?
pp. And we need to find 2 numbers that multiply to give negative 5, and those same numbers have to add to give negative 4.
1 and negative 5.
Nice.
Sorry.
Good?
Yeah.
Is it normal that one of the brackets are the same as the other? Or is that just
No. It's just, it just happens there. Alright, so we factorised it. Julia,
You're going like this.
I missed that.
It's really not hard. Just trying to show off to be cool.
Just try and
It's true, guys.
It's really annoying.
Okay.
Alright, so we're solving, so we need to do that final step to say, well, either that bracket is 0 or that bracket is 0. So p is either 5 or negative 1. Okay? So remember to do that final step, we've factorised it, and then we have to actually solve it, so we've got 5 or negative 1. Alright.
Yeah.
Now that's what I said here, the 2 has no effect, because in order for it to be equal to 0, these things are being multiplied together, yes?
I don't
The
get
2 is never going to be able to be 0. Okay?
Like 2 multiplied by negative 5 is negative 5.
No, because remember, what we're saying is that 2 multiplied by 5 take away 5. Multiplied by 5 plus 1. And so because that is 0, it makes the whole thing 0.
I don't get why p equals 5 and negative 1.
Alright, okay, let's just retreat back here. Let me just help out Gabby and Ayla first. Okay? You were clearing the 2 as well.
Oh no, I think I get what you mean.
Okay, you happy now? No. So, remember, these things are being multiplied together, yes? The concept of solving a quadratic is that we can put it in brackets because that means that we know that because we're multiplying, that one of the things we're multiplying has to have a value of 0 if the answer is 0. Okay? Stop messing around. Now, this 2 can never be 0. It's a 2, yes? So, we just need to focus on the brackets, because as long as one of our brackets is 0, the whole thing is still going to be 0.
Okay.
So the 2 plays no part and doesn't affect our choice of numbers. It's just the bracket.
So if the numbers outside of the bracket, basically just
Yes.
leave it there.
Now, if this said 2p, that's a different story.
But if
Okay.
it was just like a
But if
number-
it's just a number, then it has no effect. The 2 was just brought to the front to help us factorize it a lot easier. Okay? Julia, back to your question, why is it 5 or negative 1? Because in order for something to be equal to 0, when we're multiplying things together, one of the parts has to have a value of 0. This is what we learned when we first
So remember,
I know,
like,
but I forget.
like, cause it could be like,
Those are opposite.
since we don't know what like p really equals, since we haven't like solved it yet,
Yeah.
it could be like p could equal, like in that bracket, p could be 5, and positive 5, and then positive 5 minus 5 is 0, or p could be negative 1, and then negative 1 plus 1 would be 0. So
It's whatever
it
they want
equals-
is next to the P is what it equals.
So what we say is that p take away 5 has to equal 0 for one of our solutions to this. We rearrange this, we solve it, so that becomes p is equal to 5.
I get that. But
This
what?
one would be p plus 1 equals 0, therefore p would be negative 1. Now, you should, and ideally, hopefully you'll start to notice the more we do of this, is it's always going to be the opposite value
Yeah.
to this.
Okay. So how do you know which one it is?
Okay, so now we have to say, right, so in our normal questions that we've been doing, we have both answers, we move on, done, okay? But for an application problem, we have to say, are both of these actual options, okay? We know that they satisfy this equation, but is p possible, is it possible for p to be 5? Is it possible for p to be negative 1? So then we go back to our original situation. We've said that this is p plus 3, this is p plus 1. Well, if p was 5, then this would be 8, and this would be 6, and this would be 10. Is that an option?
Yeah.
Yeah, okay, so that's fine. That is good to go. We can keep that one. If p was negative 1, then this would be 2. Well, that's fine. This would be 0. Well, you can't have a length of 0. And then this one would be negative 2. Well, you can't have a length of negative 2.
If it's the longest too.
Exactly. So obviously, she says, hopefully obviously, this one is impossible for this particular situation. Okay? If you were just asked to solve this equation, both 5 and negative 1 are your answers. For an application question, you have to double check, are they both options? And in this case, the negative 1 is not an option. Maybe I shouldn't use the word impossible, maybe I should say not an option. Because if p was negative 1, we're getting negative lengths or lengths of 0, and that's just ridiculous.
It can it never be a negative number, or just in this case?
No, in this case. Now,
It's a shape.
often, the negative values are the ones that we can't have, okay? Often, but I'm not going to say always, because that's not always the case. They can sometimes be negative.
Wait, but in the, say we wrote p equals 5 or negative 1, and we left it like that, would that be?
You would lose a mark because you didn't recognize that negative 1 was not an option.
So, for this question, would they want us to
Yes.
just say 5?
So here, so you would write this and then say, so P equals 5.
So usually if it's always like the negative, it's like the other option is negative or more.
What did she ask?
Let's have that conversation.
No, I'm just clarifying.
Because you weren't listening to the conversation I had over here.
No, but like I'm not asking that. I'm just saying like if we got those answers, like we would automatically know it wasn't right?
No, not automatically. That's
So
what
we
I
have to
said.
work it out.
You'd have to look at the situation and double check. Okay? Many times, so I would say 95% of the time, or maybe even 99% of the time, the negative value is the one that you're going to discount. But I don't want to say always, because there could be a situation that it would be an option.
Okay.
Like in what situation?
Well, if we had here P plus 7, P plus 9, and P plus 15, you'd get whole numbers for all of them, so that's fine.
Oh yeah.
Yeah? So I'm not saying it's never an option, but majority of the time the negative values would not be the option. Okay. Erin? Now, our final thing we have to do is just double check that we've actually answered what they've asked. So here it says calculate the value of P, which we've done. Sometimes they will ask you to use your value of P for something. So they might say, find the perimeter of the triangle. Okay, so obviously the perimeter would be the distance around the outside. So you'd substitute your value in and find the actual perimeter. But just check to see what the questions ask. Okay? Next one. The length of a rectangular piece of carpet is 4 meters longer than its width. Okay, so 4 meters longer than its width. The area is 16 meters squared. Calculate the width of the carpet. Give your
Shouldn't that be a
answers right here.
rectangle?
Yeah, that's what I mean. It doesn't really matter.
Well, it looks like a rectangle on there, but it's
But yeah, it looks like a square here.
Okay. Well, so a rectangular piece of carpet is 4 meters longer than its width. Okay? The debate as to which one's width, which one's length is not something I want to get into here. Your diagram doesn't matter which one you choose as your width, which one you choose as your length. But when we have a situation like this, you can't say that this is the width, this is the length, and you have different letters. Okay? The key piece of information is that they have connected those two together. So if we're trying to find the width, and we're going to call that W, then how would I describe my length?
W plus 4.
W plus 4. Cheyenne, why did you say that?
Because it's 4 meters longer, so you're adding an extra 4 meters.
Perfect. Okay. Now, please don't fall into the trap of doing 4W, which is what I've seen a lot. Okay, 4 meters longer is W plus 4. Yeah? So, we're labeling our diagram, Erin.
Yeah. Sorry.
Okay, so let's label our diagram W and W plus 4. Now, they've given us a piece of information about the area. Well, how do I find the area of a rectangle? You multiply them together, yes? So we'd write W multiplied by W plus 4 equals 16. So far, so good, yes?
Sure.
What was that?
Yeah.
Okay, that sounded a bit weird.
What did you say?
I heard, ugh.
I heard you.
Sorry, I meant to say, yeah.
So, now I can expand this out. So I've got W squared plus 4W is equal to 16.
Meters squared.
What would I do now?
You solve it.
How do I solve it?
Wait, what are you trying to figure out?
Isn't that a difference of 2 squares?
Okay.
You rearranged the formula.
No, it's not. Never mind. No, it's not.
16 over 2 plus 35 would be 4W minus 16 equals 0.
Good, because we always have to make it equal 0. Okay, we're
Yeah.
solving a quadratic, it has to equal 0. Now, I'm going to harp on about this because it doesn't matter how many times I tend to say it to people, and people say it back to me, and we all agree that they have to equal 0. When it comes to the test, they just start ignoring that. Okay, so please don't. Please be those people that are like, yes, it has to equal 0. Let's rearrange it. So, w squared plus 4w minus 16 equals 0 because we have to take 16 from both sides.
Would it be Harrison?
Yes.
Would it be the same if you minus the w squared and the 4w?
Yes, but then you're going to end up with negative w squared. Well, it just makes it hard because remember, factorising is our preferred option if we can. Okay, you can't always. And in this case, we cannot factorise this. There's no two numbers that multiply to give 16 or negative 16, and those same numbers would add to give 4. Okay, so we would have to use a quadratic formula. In that case, then moving to the other side is fine, but you're still dealing with negative w squared, which is not added. Okay, so we're going to use our quadratic formula. So we're going to establish what are our values for A, for B, and for C.
A equals 1, B equals 4, C equals negative 16.
Awesome. Okay. Do we remember the quadratic formula? It's minus b plus or minus the square root of b squared minus.
Why are we using this instead of, why did we use this for this one and the other one for the other one?
Because can you find, are there two numbers that multiply to give negative 16?
Yes.
And those same two numbers have to add to give
Yeah.
4. Which numbers?
Negative 2 and 8.
They don't add to give 4, Angel.
Yeah, you do.
They don't know.
6. Ah, shoot. Okay.
Wait, so what do we use this for? When you can't factor
If you can't factorise them, or if you're taking too long to factorise them, you can always use the quadratic formula.
So in the other case, could we have used the...
Yes, definitely. Yeah. Okay, but this is a bit more involved. So, but if you're not confident at factorising, go straight to this. Okay, so if you are thinking, no, I hate factorising, I'm not great at it, then just go to the formula.
I found the answer.
All right, so we've got minus 4 plus or minus the square root of 4 squared minus 4 lots of, oh dear, someone needs to turn their phone on silent.
Everyone was out because she brought out her calculator.
Right, now remember our calcs, actually we can enter just these values in. Okay, so as long as we've written this, we can just enter these values into our calcs. Do we remember which buttons?
I did. I already found the answers.
Oh,
Menu.
you are amazing. So who's got it?
Algebra.
Oh, you have a question.
I just have a question.
Yep.
So that would be equal to 0?
Yes. Well, no, we're saying what's equal to 0? This?
Yeah.
No, so this is telling us what the values of W are.
Okay.
Okay, so this formula says X equals when it's X's. So these are going to tell us what the values of W are. And that's when we follow the path of one of them being plus, and then one of them is being minus. Okay?
Miss Harrison?
Yeah.
You put, the bottom one, you put 2 in brackets for.
Oh, it should have been 1.
Yeah.
Yeah.
Good job. Good catch, Erin. See, you were sleeping, but you still woke up for
Can I say the answers?
I would love you to.
Okay, so W1 equals negative 6.47.
0.47.
Yeah, and W2 equals 2.47.
Lovely jubbly. Okay, so in our case, are both of them acceptable? No. Which one do we want then?
6.
Why?
How do you
know?
Because
I mean, I didn't see the negative.
Okay, the first one's negative 6. So when you put negative into here, you're going to get, you can't have a negative left. Yes? So, not appropriate. Something. Not an option, that's what I wrote, I forgot. Okay, so this is 2 points. So W2 is 2.47. But we need to read our question. It says calculate the width of the carpet. Give your answer to the nearest centimeters. Now, these lengths here were meters. Okay,
How do
so
you know?
we've said that W is 2.47 meters. How many centimeters is that? So that's 247 centimeters. Okay, so we're good because that's a whole number. What was the next digit after this bad boy, Haley? Do you still have it on your calculator?
Yeah. It was 2.
So 2.472. So if you had said it was 2.472 meters, and then you'd said, right, that's 247.2 centimeters, you would have been penalised, or you could have been penalised there because you've written 0.2 and they wanted to the nearest centimetre. Okay? So either of these two answers will be accepted. Yes, but not the 2.472.
But that one's a meters though.
That's fine, because it's still been rounded to the nearest centimetre, and this column here represents the centimetre. But if you feel more comfortable, then just change them to centimetres. Yeah? Does that make sense?
Miss Harrison?
Yeah.
May I go to the bathroom, please?
Are you going to pee your pants?
Yeah.
Then I guess you're going to have to.
Yeah.
Alright, we do have one more. Okay, so one more example. So a right angle triangle is cut from the corner of a rectangular piece of card, 15 by 8. The base of the triangle is 2g plus 4, and its height is g.
Right here.
The remaining piece of card, the blue bit, has an area of 89. Calculate the value of g. Again, you may have had a situation where they said, show that. Okay, so don't get freaked by the show that questions. Just use your information as you would, and you're going to hopefully end up with what they had. Right, so let's put some information on here. They've said that the base of the triangle is 2g plus 4. So this is 2g plus 4. And this is g. So we're talking about these two measurements
Is
here.
that an isosceles triangle?
Oh, man.
If it was isosceles, they would both be the same. It's a right angle triangle.
Oh, I didn't see it on my paper.
You didn't see it was a right angle? It's cut from a rectangular piece of
No,
card.
like, it looks like even on that, but it doesn't.
What? But it's from a rectangular piece of card, Angel.
Just making.
What measurements did the card have?
15.
15 by 8. Okay, so we know that this whole length up here is 15, and this is 8. Okay? They've told us that this blue area, so in here, is 89 centimeters squared. Okay? So you have to use your mathematical knowledge and understanding of how we would show an expression for the area of the blue card. So have a think about it. How would we describe the blue card?
Oh,
Go, Elsa.
Well, I should first to express the area of the blue.
Yeah. Maybe just in words. Tell me what you would do.
Okay. When you would first try to find the area of the triangle, like it's like expressing the area.
Okay.
Or whatever. And then you would first find the area of the square.
The rectangle. Yeah. So the big rectangle. Yeah.
Then you'd find the area of the triangle.
Yeah.
And then you would show that the area of the rectangle minus the area of the triangle.
Good. Okay. Perfect. You happy with that?
How do you
Makes
find
sense?
the area of the triangle without the digits?
Okay, so this is where we're going to use algebra. Remember, all of these are going to involve algebra at some point. So, if we're talking about the blue area, we would have 15 multiplied by 8. So that would be my blue rectangle. Subtract the area of this triangle. Now, how do we find the area of a triangle? Base times height divided by 2. So I'm going to have g bracket 2g plus 4 over 2. I did the g first just because it's easier. Okay, so I'm just going to let you just absorb that and take that in for now. So the big rectangle, subtract the area of the triangle, so that's base times height divided by 2. And we know that that is equal to what?
89.
89. Okay, we've used all the bits of information. Sydney.
are we trying to figure out what G is?
We are, sweetheart, but we have, in order to find G, we have to set an equation up. Okay, so we use our mathematical knowledge knowing that if they've told us the value of the blue card, we use the information that we've got here, and we're going to need to use the letter G to have an equation.
Yeah, I mean, I kind of get, like, I kind of get what it means. Like, I don't know if I'd know to just, like, set up an equation with, like, the whole, like...
Okay, so I'm informing you that if you have a situation like this, you need to set up an equation with the letter unknown. And that's why they, as I say, they do often guide you and say show that. Okay? So that in itself would give you the heads up that that's what you need to do. Right, let's work out a few things that we can work out. So can we work out 15 multiplied by 8? Yeah. So that's 120. Actually, we'll keep the same place. So that's the 120. And we are now trying to expand our brackets here. So we've got G multiplied by 2G.
2G squared
2G squared
plus 4G
plus 4G, and that's still divided by 2. Is equal to 89. Okay. Now,
Can't we finish doing like the rest of the bracket inside? Can't we divide by 2 or
well, that's what I was going to say now. So this divided by 2 is a real pain in the bottom, isn't it? Yes? Because it's just making it more complicated than we would like. But if something is divided by 2, remember you have to divide both terms by 2 if you're going to get rid of it. Okay? So 2G squared divided by 2
It's G squared.
is G squared, and 4G divided by 2
2G.
is 2G. So we can do that. So we've got 120 take away brackets G squared plus 2G. Okay, so we've got rid of our divide by 2, which has been much, much easier. Now, notice I've got my brackets around this still because I'm subtracting both of these two things. Bless you.
So now just subtract 89.
So now we want to have everything on the same side because it has to equal 0. Let's expand my bracket first because I'm subtracting both of these two things.
Wait.
So I've got 120 subtract G squared subtract 2G equals 89.
Why is it
Subtract, I was saying.
Because every minus 1.
It's being multiplied by the 1.
Yeah.
Yeah, because this negative, this takeaway affects both of those two things.
Wait, Miss Harry.
Hang on, I was going to hand up, yeah?
Were you saying that in order to, like, divide out the 2, you have to do it to both sides?
Both parts of this. This is just, it's just here.
Okay.
Yeah?
Yeah.
Danny, what was your thing?
Never mind.
Okay. Now, as I say, I can't say it more enough. I don't like negative G squared, so I'm actually going to move these 3 things here to join the 89. Okay. So I'm going to take away 120 from both sides. I'm going to add G squared to both sides, and I'm going to add 2G to both sides. So this is all gone. That's a 0. What's 89 subtract 120?
Minus 31.
Nice. And then we've got plus G squared plus 2G. You have good mental maths, Hayley.
Thank you.
She's always been like that.
You think she's a bit mental.
It
I'm
is.
so funny.
He's a smart boy.
I actually should be on stage at some point. See my name in life. Comedy by Miss Harrison.
A equals negative 31, B equals 1.
Oh, now, here we've got to be careful.
Alright.
Okay? So we've written it in the order that we had them here, but that's not the order we're used to seeing things, is it? So if we were going to use our quadratic formula, A wouldn't be negative 31. What would A
1.
be?
Negative 1.
Not even negative 1.
It's just 1.
A would be
Oh, 1.
1.
Right.
B would be 2, and C would be negative 31.
Wait, what? Why
Oh, wait,
is
doesn't it
that?
go backwards?
No, because
Okay, so we have to remember that for our quadratic formula, it says ax squared plus bx plus c. So you're looking that A is always the digit or the coefficient of the x squared, the
What
squared
if
term.
there is none that's x squared?
And it's
So
not
it's not
quadratic,
quadratic.
and therefore you're not going to use a quadratic formula.
Perfect.
Okay? You answered your own question a little bit. Oh, I don't know why I just did that. So, minus 2 plus or minus the square root of 2 squared minus 4 lots of 1 lots of negative 31 over 2 times 1.
Do we have to write this equation?
No, give it. But to be honest, the more questions you do, it's just if you are, we might
got
be
the
able
answer.
to. 31's a prime number, so I'm guessing it no. So,
I got the answer, Miss Harrison.
what's the answer, Haley?
G1 equals negative 6.66 and G2 equals 4.66.
It's definitely 6.6, not 6.7.
No, well, it was 6.56,
Oh,
but then I rounded it out.
you are.
It's over 2. So then,
So
now,
are either of these suitable, more suitable, less suitable?
this one, 4.
Okay, this is the one we're interested in, not an option. And what have they asked us to do? Calculate, give me your answer to 2 sig fig.
So it would be 5.
So if they want 2 sig fig,
It'd be
we say
4.7.
G is 4 point. Wow, what was it? 4. Oh, hang on. So it was, yeah, it would still be 4.7. Is it, what is it? Meters, I think, isn't it?
Centimeters.
Centimeters. Apologies. Yeah.
You can still put the 0 at the end, can't you?
No. No, 2 significant figures, you've got to just have digits. As soon as you put zeros after a decimal point, they're counted as significant. Okay? If the only time we put zeros in or leave them there is if you need it to keep the value of it. So, for example, if you had 2743, bless you, and you wanted it to 2 significant figures, it wouldn't then be 27. You'd have to have the 2 zeros to keep its value. Okay, 27 is very different to 2700, whereas 4.7 is no different to 4.70. Okay, so you mustn't put the 0 in unless it's changing its value. Right? How do we feel about those? Yeah?
Yeah.
They're not too bad. It's just getting into the habits, and to be honest, the application style of it is it could use any element of maths. So we've looked at Pythagoras' theorem,
It's
we've
kind of
looked at
fun.
area, there's another area one. So it could be anything that they do, that they use mathematically, they're applying it to quadratic equations. Okay?
It's like a puzzle.